For more similar videos, kindly turn on the notification button and subscribe to my channel. Like and share the videos. Now, we want to talk about how to find the value of unknown when two exponential expressions are set equal to each other. In other words, we want to talk about what we call exponential or indicial equations. Example 2 requires us to solve. So we want to take them one after the other and see what we're going to get. So the first one is anytime you are giving exponential equation, what you have to think of doing is ensure you express each side of equal sign in its index form. So here, 2 to the power of x plus 1 is already well expressed in index form with 2 being the base and x plus 1 being the power. So to the right, we have 64. Express this 64 in index form. 64 in index form, one number multiplies itself certain number of times that gives 64. It is 2. 2 multiplies itself 6 times to give 64. So 2 to the power of 6. Or if you refer to the table given in example 1. As the students of indices, we need to try and memorize them. In this case, the moment you're able to, our target is to express each side of equal sign to the same base. Once the base are equal on each side, you can equate the power. So you now say equate powers because the base are already equal. That is x plus 1 equals to 6. Then you just solve this using your previous knowledge of solving linear equations. You have x equals to 6 minus 1 and x equals to 5. It is important to also note that sometimes it is the power that are equal on both sides. For example, if you are solving something like a to the power of 7 equals to 3 to the power of 7. Since it is power that are equal on both sides, you equate with the base. The base a equals to the base 3. So that is what you will get. We'll quickly go to the B part of example 2 and see how we can have that also solved. The B part says two to the power of 3 minus y times a to the power of y equals 4. Express each of them first to the same base. So this is already expressed as 2 to the power of 3 minus y times, express this 8 in power form, it becomes 2 to the power of 3. New power will multiply with power. So 3 times y is 3y. So we have 3y there equals to 4 in index form is 2 to the power of 2. Now, our target is to equate the powers at the end of the day. But if you look at this left-hand side, make it a single base before you can do that. To make it a single base, we now remember our laws that say, one of our laws that says a to the power of x times a to the power of y. Same thing as pick one base, add the power of. So that's what we want to apply there. We'll get 2 to the power of 3 minus y, then plus 3y equals to 2 to the power of 2. Since the base are equal on both sides and just one base on each side, you can equate the power now. You can equate the power. So equating power, we have 3 minus y plus 3y equals 2. And if you simplify this, negative y plus 3y will give us 2y equals to 2. Bring 3 to the other side, minus 3. And you have 2 equals to negative 1. To get the value of y finally, we remove this coefficient of y. And to remove it, since this coefficient multiply the variable y, you divide both sides by it, you do the opposite. So we're going to get 2y over 2 equals to negative 1 over 2. And hence, y equals to, because these 2 here will cancel out, minus 1 over 2. That's the answer to the B part. We move on to C quickly without wasting our time. The C part says that the square root of 8 to the power of C says square root of 8 to the power of x equals 64 times 7 to the power of 0. First of all, express this in power form. 8 to the power of x, same thing as 8 is same thing as 2 to the 8 is 2 to the power of 3. 3 will multiply the original power x. But we told us anytime you have roots, this one now is square root. That means there's invisible 2 here. And every root is a power of reciprocal. For example, if I have root a or 8th root, so of p, so it will mean p to the power of reciprocal of that a, that is 1 over a. So if I have square roots here, it will be 2 to the power of 3x. So the power of the root will now be 1 over 2. Equal to 64 is 2 to the power of 6 times 7 to the power of 0. Anything to the power of 0 is 1, except 0 itself. For example, if I say 5 over 5, 5 over 5, you agree with me, is 1. If I now use the law of indices, 5 over 5, this one is power 1, this one is power 1. Since the base are the same, pick the base, subtract the power, 1 minus 1. Use the law of indices that says a to the power of x to the 8, divided by a to the power of y is a to the power of x minus y. So you subtract the power if the base are the same. The base are the same, 5, subtract the power. And 5 to the power of 1 minus 1 is same thing as 5 to the power of 0. So the value that gives 1 here is same thing as the value that gives 5 to the power of 0. That means 5 to the power of 0 is 1. Hence, any number, any non-zero number that is to the power of 0 is 1, except 0 itself. 0 to the power of 0 is undefined. So this one is 1. And from here, we have 2 to the power of 3x over 2. If you simplify the fraction, multiply 3x times 1 over 2 is 3 to the power of 3x over 2, which is 2 to the power of 6. Anything times 1 is that thing. From here now, we can see the base are the same on each side. We can equate power. Equating power, we have 3x over 2 equals to 6. And for us to clear the fraction, we cross multiply. 6 means 6 over 1. Cross multiply. 1 will multiply 3x. You have 3x. And 2 multiply 6. We have 12. And finally, to get the value of x, we divide both sides by this coefficient of x, which is 3. 3x over 3, we have x. 3 will cancel 3. And 12 divided by 3 is 4. So we have 4 as our answer to the C part. And quickly, we want to solve the last one, that is example 2, which is the D part. In the D part, we have 27 to the power of negative x equals to 3 to the power of x plus 1 times 9 to the power of 2x, all divided by 81. Of course, there are two ways. You can choose to simplify each of them, express each of them in power form in their own side. And at the end of the day, you use the law of indices for addition and subtraction, for multiplication and division to simplify their base to a single base. If you don't want to do that, since this one is in fractional form, you can cross multiply to clear the fraction. You see this one as this 27, you see it as over 1. So when you cross multiply, 21 will go to the other side to multiply this. So you have 27 to the power of negative x multiplied by 81 equals to 3 to the power of x plus 1 multiplied by 9 to the power of 2x. Now you can express each in index form. 27 is 3 to the power of 3. The new power will multiply the old power. Don't forget. So negative x here will multiply that 3 times 3 to the power of 4 is 81. This one is already in power form. And 9 is 3 to the power of 2. But because new power will multiply old power, so here, just the left-hand side here, since the base are 2 here and they are the same, use the multiplication law of indices. So we have 3 to the power of 3 times negative x is minus 3x. Then add this 4. You know, you are adding the power here and the power here together. Since you choose a single base, you factor into single base. You remember a to the power of x times a to the power of y is a to the power of x plus y. So from here, the second one is 3 to the power of x plus 1. Then plus the power of the second one here is 4x. And since the base are equal on both sides and it's just a single base on each side, you are free to equate the power now, which will give us 3x plus 4 equals x plus 1 plus 4x. You can now solve this linear equation by collecting like terms. So you have negative 3x. This one, x plus 4x is already 5x. Move 5x to the other side, you have minus 5x equals to 1 minus 4. This gives us negative 8x equals to negative 3. So from here, we can divide both sides by coefficient of x, which is negative 8. And that will give us negative 8x over negative 8 equals to negative 3 over negative 8. So from there, we see that minus 8 cancels minus 8. Minus divided by minus z, just like law of multiplication. Minus times minus is plus. Minus divided by minus is plus. So we have x to be 3 over 8. Eventually, x to be 3 over 8. That's the answer for example 2. We move on to example 3. For more similar videos, kindly turn on the notification button and subscribe to my channel. Like and share the videos. Thank you.